Hello students, let's take a look at this question. So in this question, we are supposed to find the trigonometric Fourier series for the periodic signal shown. So this is the periodic signal. When you have a signal like this, it is important to note whether the signal is even signal or odd signal. So let's write the conditions for even signal and odd signal. So even signal is of this format. F of t is equals to f of minus t, and then odd signal f of minus t is equals to minus f of t. So let's look at the signal and see which one that it is likely to be likened to. So here minus 1 to 0, the value is 1. And then 0 to, this place is supposed to be 1. Alright. So minus 1 to 0, the value is 1. And then 0 to 1, the value is also what? 1. So you can see that f of t, which is 0 to 1, the positive aspect, the value is 1. And the negative aspect, f of minus t, the value is also what? 1. So that means that f of t is equals to what? F of minus t. Because both f of t and f of minus t have a value of what? 1. Because minus 1 and 0, you see that the graph is going this way. So minus 1 and 0, the value is what? 1. And 0 and 1, the value is what? 1. So it's an even signal. If it's an even signal, then what it means is that our Bn is going to be what? 0. Because we know that sine t is an odd signal, and then cos t is an even signal. So if this signal is an even signal, that means that the odd aspect will be 0, and the odd aspect here is sine. So let's write the general equation. So this is the general equation for Fourier series. F of t is equals to a naught plus infinity 1, and then here is an cos nt plus Bn sine nt. So here, because it's an even signal, the odd aspect, which is sine t, is going to be 0. And then we have to find the even aspect. Okay. So now the next thing is that we must determine the period of the signal. The period is the time it takes for the signal to repeat itself. So this signal, you can see that when does it repeat itself? When it goes this way, comes this way, comes this way, comes this way, it has what? Repeated itself. Alright? And then so that is when it repeats itself. When it goes this way, comes this way, goes this way, comes this way. So I can say that my period is from here up to where? Here. Okay. So that is 1, 2. There has to be 2 here. So 1, 2, 3, what? 4. 4 spaces. From minus 1 to 0, 0 to 1, 1 to 2, 2 to what? 3. So that means that t is equals to what? 4. Okay, so now if t is equals to 4, I know that omega naught is equals to what? 2 pi over what? T. That means that omega naught is equals to 2 pi over 4, which is equals to what? Pi on 2. Okay, so that is equals to pi on 2. Now knowing this one, we can now find our A naught. So we're going to find our A naught here. So now A naught is equals to integral here 1 over t is supposed to be here. Here you can see that t naught and then t naught plus what? T, or you can say negative infinity to infinity, or you can say t naught into, and then here t naught plus what? T, into what? F of t dt. So let's see the function for this graph. This graph here, the value is what? 1. So this f of t will be what? 1. Okay, so this is equals to 1 over, our period is what? 4. So 1 over what? 4. Okay, we're going to have a period which is what? 1 over 4. So we are starting from what? Here is starting from -1 to what? 3. So I'll put here -1 and I'll put here 3. Here, see that this signal, okay, is a unit step signal. And the unit step signal, the value is what we use. So the value here is what? 1. So I'll just say what? 1 d what? T. But if you take a look at this particular function, what you can see, wait a minute. Let me not just put here to be 1, okay? Let me continue to maintain here to be what? F of what? F of t, okay? For some reason, let me continue to maintain here as what? 1 over 4 integral -1 to 3 f of t d what? T. So now, if you take a look at this particular waveform, you see that from this part up to this part, the value is what? 1. And from this part up to what? This part, the value is what? -1. So from here, here, the value is what? 1. Here, the value is what? -1. Okay. So that means that from -1 to 1, the value is 1. 1 to 3, the value is what? -1. Okay. So that means that this signal will have to be broken down into 1 over what? 4 integral what? -1 to what? 0. Okay. Here the value is what? 1 d what? T. Okay. So minus, because you see that this place the value is 1. Here the value is what? -1. So I'll bring this minus first. Minus, it's starting from what? 1 to 3. 1 to what? 3. Okay. Here 1 d what? T. You see that here the graph, this part, the graph is positive. Okay, the graph is positive. But this part, the graph is what? Negative, because it's what? -1. So I brought minus and I brought the 1 here. Okay, so this part, the graph is what? Negative. Okay, so when you have this one, what you do is that you integrate it. 1 over what? 4 into, if you integrate 1, you get what? T. So you get t into -1 and 0 minus here you get what? T. Here let me write. You see that here is 1 over 4. You see that here I'm supposed to bring 1 over 4 here also. So let me bring the 1 over 4 here. Okay. So that is what you get. So into what? T. 1 into what? 3. So now here, always you put in the upper limit first. So 1 over what? 4. 0 minus what? 1. Okay. And then you have minus 1 over what? 4. 3 minus what? 1. So what do you get? You're going to have 1 over what? 4 into what? Into 1. Okay. You're going to have 1 over 4 into 1. Okay, 1 over 4 into 1. All right. And then here, you're going to get minus 1 over what? 4 into what? 2. So, wait a minute. Let us see something. We have made a mistake, okay? You see that we have made a mistake. You see that here, it is what? -1 to 1. It is not -1 to 0. So, we are supposed to put -1 to what? 1. Okay. So, sorry, we made a mistake there. So, here, it's what? -1 to 1. 1 to what? 3. So, -1 to 1, the value is what? 1. So, -1 to 1, the value is what? 1. And then 1 to 3, 1 to 3, the value is what? The value is what? -1. But I brought the 1 here and I brought the minus what here. Okay, so it's the same. So here is -1 to 3. So now here, here is -1 to what? 1. So here is -1, here will be what? 1. Okay, so now what it it means is that I am going to put in my limits. Okay, so if I put in here, it's going to be what? 1 minus what? 1. So here, in that case, here will become what? 2 minus what? 2. So this will give me what? 0. That means that A naught is equals to what? 0 for this particular graph. Why is A not giving me 0? Why is A not giving me 0? It's very simple. So you see that this part is the same thing as this part. Okay, this part is the same thing as this part. What it means is that the DC component or the DC value, this part and this part, they are equal, so they cancel out. So when they cancel out, it will be equals to what? 0. So the average value or the DC signal of this particular waveform is what? 0. So the average value of this signal is 0, because this part and this part, they are the same, so they cancel out. This part and this part, they are the same, so they ought cancel out. So the average will be 0. So the average value, which is what? A naught, is what? 0. A naught is called the average value or the DC what? Value. All right. So let us proceed to find our AN. So we know that AN is equals to 2 over T. 2 over T integral. 2 over T integral. Here I can say that T naught. T naught plus what? T. You can say T naught, or you can say what? Negative infinity to what? Infinity. Okay. And then I'll have what? F of what? T into what? Cos nt d what? dt. Okay. Cos nt dt. Okay. Wait a minute. I think I have made a little mistake here. Okay. So it will not be cos nt dt. So let us cancel this one and then redo this part. So now it's going to be what? AN is equals to what? 2 over T into what? T naught into what? T naught plus what? T into what? F of what? T cos n omega naught what? T dt. But we know that omega naught is equals to what? We found omega naught. What did we find omega naught to be? We found omega naught to be pi on 2. Okay, to be pi on 2. So now we know that omega naught is pi on 2, but omega naught is pi on what? 2. So now we're going to put this pi on 2 here. So now I will have AN is equals to 2 over T. What is T? Okay, we found T to be 4. Okay, so that means that I'm going to have what? 2 over what? 4 into T naught and then T naught plus 1. So my function is starting from 1 and it's ending at what? 3. Okay, so here F of T into cos n omega naught, which is what? Pi on 2. Okay, which is n pi on what? 2 what? T d what? dt. Okay, so this is what we have right now. So now from here we can move forward. Okay, so moving forward, what we can do is that we can now introduce our limits. Okay, no, it is important that we introduce our function, okay, our function into the equation. So here, what you can see that if I should even simplify further, I'll have 1 over 2 from this part, okay, and I can still maintain minus 1, and I can still maintain 3. I can have my f of t cos what? N cos n pi on what? 2 t d what? dt. Okay, so now that I have this one, I can move forward. So now I can say that an is equals to 1 over what? 2 into what? let me break the function into two, just as I did over here, where I broke the function into what? 2. Okay, so now if I break the function into 2, I'll have minus 1 to what? 1. Then I'll have what? 1 here, and then I'll have cos what? N pi t over what? 2. Okay, and then I'll have minus, here I'll have 1, and then I'll have what? 3. I'll have what? 1 cos n pi t over what? 2. Okay, so here you can see what? The t. Here you can see the what? T. Okay, so now what I have written is the same thing as having, here I must bring 1 over what? 2. 1 over what? 2 into what? Minus 1 and 1. This 1 cos n pi t dt over 2 is the same thing as what? Cos n pi t dt, because anything multiplied by 1 is that same number. So I'll remove this 1 here, and then I'll have what? Cos n pi t d what? Over 2 d what? T minus 1 over what? 2 into what? 1, and then into 3 into cos what? N pi what? T over 2 d what? dt. Okay, so this is what I can have at this particular stage. Okay, so now what I have to do is that I have to integrate my functions. Okay, so integrating my functions, what I will have is that an is equals to, here, integrating this one, I can have 1 over 2 here, and then I can have, whenever you integrate cos, what you're going to have is that you're going to have what? Sine. Okay, so I'll have sine n pi t, okay, over what? 2, okay, over 2, okay, all over what? N pi t, all over n pi over what? 2, okay. So if I should divide this same function by what? N pi over 2, then what happens is that the 2 will come up, and then the n pi will come what? Down, okay. So for example, what I'm saying is that this one here is going to be divided by what? N pi over what? 2, okay. So if I have this one, then let me just, it was just to show you. So here, an is actually going to be what? 1 over 2 into what? This n pi t will become what? 2 over what? N pi, okay, sine n pi t over what? 2, okay. So this is what I'm actually what? Going to get at this particular stage, okay, at this particular stage, okay. And then I'll have, I'm going to have, it's going to be, here, let me bring this minus sign. So here will not be plus. I'm sorry, here will not be plus, okay. It will be what? It will continue to be minus. Let me bring the 1 over what? 2 into what? Into, here, it will be just like this one. So it will be what? 2 over what? N pi. Because whenever you are integrating cos, you get what? Sine over the what? Angle. So it will be sine n pi t. So it will be sine n pi t on 2 over n pi over 2. So that n pi over 2 will become what? 2 over what? N pi. So I'll have here sine n pi t over what? 2. Okay? All right. Okay. So this is what I am going to have. So here my limits are minus 1 and 1. And here my limits are 1 and then what? 3. Okay. So those are the limits that I am going to have at this particular stage. Okay. So now here I'll have to what? Introduce my limits. Okay. From here I have to just introduce my limits. Okay. So now I will introduce the limits, and I will have an is equals to 1 over 2 into an is equals to 1 over 2 uh, into what I'm going to have here. So here I can say that I'll bring this one here, 2 into over what? N pi into what? Sine. I'll always you introduce the upper limits first. Okay, to what? Sine n pi. Okay, it will be what? Sine n pi over what? 2. Okay, sine n pi over 2. And then here it will be what? Then the lower limit. So this is for 1. So now minus 1. So minus, okay, minus what I am going to get over here. Okay, so here is going to be, I just have to bring this one here. Okay, minus sine minus 1. Okay, so here n pi over 2. Okay, so this minus 1 will be what? Minus minus. Okay, because the sign will also become minus. So now this one will now become what? Plus. Okay, now this one will become plus. Okay, all right. So this is what I'm going to have at this particular stage. Okay, now this minus, I'll bring it again. So now if I bring that minus, I'll have what? This 1 over 2 will come here, and then let me bring this one. So the the upper limit first. You introduce the upper limit first. So 2 over what? N pi into sine n pi sine 3 n pi. Okay, so sine what? 3 n pi over what? Over 2. Okay, over 2. Then you're going to also have minus. Okay, the next one is going to be what? Minus. Okay, so I'll have minus sine n pi over what? 2. Okay, so this is what I'm going to what? Have. Okay, so this is what I'm going to have. Okay, so now this is what I am going to have. Okay, but you see that basically here and here is the same. Okay, and then this one is negative. The only odd one out, the only odd one that we have is this one. Okay, but from our knowledge in trig, we know that sine 3n pi over 2, okay, is equals to sine 2n pi, sine 2n pi minus sine n pi over what? Sine n pi over 2. Okay, so but this one basically what happens is that in the third quadrant, it is actually equals to what? Minus sine n pi over what? 2. Okay, so where I have this one, I'm going to put this equation over there. Okay, all right. So now moving on from there, what I am going to get is that I am going to have an. I'm going to have an is equals to 1 over 2. An is equals to 1 over 2 into let me write the original equation that we had again. Okay, so I'm going to have an is equal to 1 over 2 into what? 2n pi into sine n pi over what? 2 plus sine n pi over what? 2 here like this. Okay, minus 1 over 2 into 2 over n pi into sine n pi over what? 2, okay, into sine what? N pi over 2, all right? So this one minus, okay? So here, I told you that, you see that I have written this one here, 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 I have written this one here. This minus is this one. This half is this one. This one is this one. This one is this one. Because I told you that this one in the third quadrant is this. So now, instead of writing this one, I'm going to, it's the same thing as what, or it's equals to this one. So I'll be writing this one. So that is what I've written here. Okay, so I'll be bringing the minus here. Okay, so I'll bring the minus here, and then I'll bring minus sine n pi over 2. So here, then I'll close my bracket, and then I'll do it this way. Please, let me write it again so that it will be more clear. An is equals to 1 over 2 into 2 over n pi into sine n pi over 2 plus sine n pi over 2, okay, minus, okay, 1 over 2 into 2 over n pi into minus sine n pi over 2 minus sine n pi over 2, okay, then you just what, close it like this. All right, so that is what you get at this particular point, okay, at this particular point. So now you can see that if you have sine n pi over 2 plus sine n pi over 2, you're going to get what? 2 sine n pi over 2. So that 2 will come and multiply here. So in that case, you're going to get what? An into what? 1 over 2 into what? That 2 will come and multiply, so you get 4 here. So 4 into what? N pi into what? Into sine n pi over what? 2. Okay? That's what you get here. And here you get what? Minus 1 over what? 2. Okay, so that here too you get 1 over 2. Okay, so here you're going to have, here also you're going to have, what you're going to have is that you're going to have minus sine n pi over 2 minus sine n pi over what? 2. Okay, so if you bring minus 2, then basically here you're going to have minus minus 4, okay, over what? N pi into what? Sine n pi over what? 2, okay, over sine n pi over what? 2, okay. So now you can see that an is equals to, so now you can see that an is equals to, you can, this half is common to the two of them, so you can bring it out, and then you can see that 4 n pi into what? Sine n pi over what? 2. Minus minus, it will become what? Positive. So here I will have plus what? 4 over what? N pi into what? Sine n pi over what? 2. Okay, so that is what I'm going to get. Okay, so now here I'm going to get what? These two are the what? They are the same. Okay, they are the same. So I can say that 1 over what? 2 into what? Into let me say that I can say that into here, if you add these two, you get what? Here, let me make it this way. Okay, let me use this kind of bracket. You get 2. So if you multiply 2 by this, you get 8. So over what? 8 what? N pi into what? Sine n pi over what? 2. Okay, so now if you cancel here, then you're going to get what? 4 over what? N pi into what? Sine n pi over what? 2. So this is what you're going to get. So at the end, an is equals to what? 4 n pi into what? Sine what? N pi over what? 2. Okay, so this is what? Your an. Now you have what? Your you have your an. Okay, now you have your an. All right, so now if you have your an, you can just put it in the original equation. In the original equation, which is what? F of t into what? A naught plus what? Summation up to what? Infinity n is equals to 1 into what? An cos what? N omega naught what? T. And then plus what? Bn sine n omega naught what? T. We know that Bn is what? 0 because it's an even function. And then a naught also, we got it to be what? 0. So then only an remains. In that case, our function is now equals to this. I hope you can see. So here n is equals to what? 1 into this function, which we got what? 4 over what? N pi into what? Sine n pi over what? Over 2. Or into what? This one into what? Cos n omega naught. We got omega naught to be what? We got omega naught to be what? Pi on 2. Okay, so pi on 2. So n what? Pi on what? 2. Okay, and then here is what? T. Okay, so this is what we have. Now, what you can do is that you can expand your you can expand this equation. This is the Fourier series, but we can expand our Fourier what? Series. Okay, we can expand our Fourier series. If we want to expand our Fourier series, in that case, let's do something. We can say that this 4 over pi is a constant. So summation, this one, n is equals to what? 1. Let's bring 4 over pi what? Outside. Okay, so if you bring 4 over pi outside, you have what? 1 over what? N. 1 over n into what? Sine what? N pi over what? Sine n pi over 2 into what? Cos n pi t over what? 2. So now n is equals to what? 1. Okay, so one thing we have to also note is that we got this one for the limit, what? Minus 1 into this one, 3, and then here is what? 3. Okay, so we got it for this one, minus 1. This is the limit with which we got the function, or the period with which we got our series, or we got our Fourier series. Minus 1, t, here, 3. Okay, so now here, what we're going to do is that, let us put in 1. Okay, if we put in, because n is starting from 1, if we put in 1 over n, sine what? If here sine n, what is sine? If n is 1, that means that sine pi over 2. So if you want to know sine pi over 2, then what you do is that you must draw the what? The sine curve. So this one is what? This one here is what? 0. So sine is what? Sine is like this. Okay. Okay. So here is 0. So here is what? Pi on 2. Here is what? Pi. Here is what? Here will be what? 2 pi. So here will be what? 3 pi. So here will be what? 4 pi. So here we are going to have what? Sine n pi over 2. And if n is 1, that means that I am going to have what? I am sine pi. I'm going to have sine pi over 2. And sine pi over 2 is what? 1. So that means that the whole of this one, I'm going to have what? 1, because here 2 will be 1 over 1, which is also 1. So I'm going to have what? 1 into what? Cos, here is 1. So cos what? Pi t over what? 2. So that means that f of t is equals to what? 4 over what? Pi. Okay, I hope you can see. 4 over what? Pi into, I'll not be in the summation again because now I'm expanding the series. Into what? Into here, I got 1 here. So I'll get what? Cos what? Pi. If here is, I'll get cos what? Because here is 1. So it's going to be cos what? Pi t on what? 2. Okay, now let me put in what? 2. If I put in 2, that means that I'm going to get sine 2 pi on 2. Okay, so what is sine 2 pi on 2? Okay, so what is sine 2 pi? Okay, sine 2 pi on 2. So let us see. Okay. 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 Let me see. Okay. So now here, what we can see is that basically sine 2 pi is basically what? 0. Okay. Sine 2 pi is what? 0. So that will give us, if here becomes 0, that means that the whole series will become 0. So now let's put in what? 3. If we put in 3, then we are going to have what? Sine 3 pi on 2. Okay. So where is sine 3 pi on sine 3 pi on 2? Okay. So sine 3 pi on 2. So if sine 3 pi on 2 basically will be here. 3 pi on 2 will be here. Okay. Because if here is half, here is 1, here is what? 1.5. So 3 pi on 2 will be what? Will be here. And here is what? Minus 1. So minus 1 into what? Cos nt, cos what? 3 pi t over what? 2. Okay. So I'll have what? Here will be 1 over 3. So I'll have minus 1 over 3. So here is giving me what? Minus 1. So the minus is here. So it will be what? Cos, here will become what? 3. And then it's going to be what? Pi t on what? 2. Okay. Now, let me see. If I put in 4, I'm going to have what? Sine what? 4 pi. Okay. Sine 4 pi on 2. Okay. Basically, sine 4 pi on 2 would be what? 0. Sine 4, even 4 pi itself is 0. 4 pi on 2 will be what? 0. So let me put in 5. If I put in 5, I'm going to have what? Sine 5 pi on what? 5 pi on 2. Okay, 5 pi on 2 is going to be something which is what? Here. This is what? 5 pi on 2. And the value is what? 1. So if here is 1, then it's going to be what? It's positive 1 because it's here. See, 5 pi on 2 is here. Positive 1. So plus what? 1 over 5 cos what? 5 pi on what? 2 and t. So this will be the series as what? As you go on. And this is, so you see that the function is actually defined for what? For the odd numbers and not for the what? Even what? Numbers. So let's say n is, so here n is equals to what? 1, 3, 5, on and on and on. And it is defined for the what? For the interval, okay? Or for the what? Period. A period is always an interval. What? Minus 1 less than what? T less than what? 3. So this will be the end of this particular question. Thank you so much.